Hey folks, so today we have Arghya Chowdhury with us who will be talking about how to level up your decentralized application using cross-chain functionality and tools. Let's welcome him on the stage.
Hey everyone, thanks Audrija for this warm welcome, and thanks to GDSC Triple IT Kalani for giving me this opportunity. Just a second. Yep. Really sorry for the delay. So let's start our session. Okay. So today our session's topic is how you can level up your Dapp and build on cross-chain. So let's start with the basics first. Like say, what is blockchain? Uh, let's start. Hold on, give me a sec. Give me a sec. Yep. Hello, Tamagno. Hello, Adrija. All right. So let's start with the basics. What is blockchain? Now, blockchain is basically a DLT. It's a decentralized ledger technology, right? So now say, what is ledger? Ledger is basically kind of like a notebook where like you are keeping records of multiple transactions over there. Now, say that in a classroom, everybody has this same ledger in their desk, right? एक सबके पास है, सबके पास सेम लेजर है, सेम नोटबुक है, and whenever the say for example the class teacher, let's say the class teacher writes down something on the ledger or the notebook, तो वो सबके जो notebook में है वो आ जाता है. Okay, at the same time, this is basically blockchain, and this is basically the technology that blockchain is built on. Now, let's say that see, from the name you can understand what blockchain exactly is, like, right? It's basically a chain of multiple blocks. Now, what I mean by multiple blocks is that, see, what does this blocks contain? These blocks contains records of transaction data, right? It contains records of transaction data, and these are connected to each of the block. So how does the whole architecture look like exactly? Like how does it even connect? You might be wondering. So see, each of the block in a blockchain has the hash of the previous block. It has now it has the previous hash of the previous block, and it has the parameters and all. It has the transaction details, and also it has if we're trying to give it some transaction data or trying to record something there, so it has that info as well. Okay, and then all these blocks are chained together, so see, if something is on blockchain, say for example an NFT. Okay, now an NFT can be anything. It can be an image, it can be a video, it can be an audio file, it can be a GIF file, anything at all. So all this, like any of these files are on blockchain as an NFT. Then what happens is that you can't exactly erase it, right? You can't erase anything from the blockchain because, see, as it is a chain, like if from see, here is a block and it's a part of the chain, right? It's in the middle. So if you're trying to remove this, if you're trying to erase this, you can't actually do it. like because if you were to like remove this block entirely from the blockchain, then you will have to remove the past, not the past actually, the later ones that has the hash of this block in them. You have to remove them as well, so which is technically almost impossible. Now, is blockchain tamper-proof? Not really, but it's close to being tamper-proof. At least it's better than the Web2 solutions. That is why this ledger technology came into help, and this is one of the ever-growing technology currently in the IT industry. And we will move on to the next page. Yep, dApps. Now, what are dApps? dApps are basically, when is it starting? Lol, it's already started. Uh, okay, hello, Arav. Yeah. So, what are dApps? dApps are basically decentralized applications which are built on blockchain. Now, see, when you're building a blockchain, not a blockchain, sorry, my bad. When you're building a decentralized app on a particular blockchain, what happens is that that app only is working on that particular blockchain, right? But it's not exactly working on cross-chain. What I mean by cross-chain is that it doesn't get to interact with other blockchains. Like suppose if you are building a dApp, you're building a decentralized application on Ethereum. So it only works on the Ethereum chain, right? Say for example on the Ethereum mainnet. So it only works on the Ethereum mainnet, and it can't really interact with the other blockchains such as Polygon or Avalanche, Solana, or anything, right? So how can we make our dApps go from one chain to multiple chains and make it go cross chain basically? So this is where it comes to help. These protocols I will be talking about, the tools I will be talking about, makes your dApp go cross-chain basically, and that's the best part about it. So yeah, okay. Also, these cross-chain dApps have like different names for each of the protocol. It will be moving forward and talking about different tools, and I will be mentioning what names they have given to their cross-chain dApps. Also, hold on a second. Yep, you did see Gojo. Yeah. So, okay. I think I forgot to add one of the slides here, but yeah. As we're talking about blockchain, I think it's important to talk about layers as well to actually give you the whole idea of how the whole blockchain architecture looks like and how the protocols we'll be talking about later on, how they are actually helping the main blockchains, right? How they're built on top of them. So, see, there are multiple chains in blockchain, the whole architecture basically. So first to start with the layer 0. Now layer 0 contains the hardware parts, the nodes, the computers that actually provide the foundation part of any blockchain, right? That's called layer 0. On top of that, when you're building, you're writing smart contracts and you're actually building a blockchain there, you're actually recording transactions there, and as well as recording the hashes and making a blockchain basically. That's when it's called layer 1. And it has like there are multiple layer ones, such as like some of the most popular ones are Bitcoin, Ethereum, Solana. Now, what are the differences between these layer ones? See, every layer one has a consensus mechanism. Like, see, for Bitcoin, it works on the proof of work, proof of work consensus, and for Ethereum, it works on the proof of stake, and for Solana, it works on proof of history. So there are different kinds of systems and things that actually these blockchains work on, these layer one blockchains work on, and they have difference as well. Like see, Bitcoin is slower example, like for example, Bitcoin is slower, Ethereum is slow as well, while Solana is quite fast. So yeah, there are multiple differences between these. And also now, See, that was the layer one part. Now let's go to the layer two. What exactly is layer two and how it is connected to layer ones? See, so layer two is basically, it's more of an application layer, like where you are actually building something on top of layer one, and you are interacting with it, right? Say, for example, if I give you an example, I think it would be better. Like you can understand it better that way. See, one of the example is push protocol. Push protocol is a service that is on layer one blockchain, Ethereum, right? So what these layer 2 blockchain have is that, like, what do this even offer? Like, why do we even need layer 2 blockchains? What this offer is that more, there's a term called side chain. We'll be talking about that later. And it also provides, more sustainability, more, features and stuff, so that it can be more dependable. Like, see, Polygon is a layer 2 blockchain, and Polygon is built on Ethereum. And what I mean by sidechain is that it's a record of transactions. It's a record of transaction set that is, it's on the, like, see, Polygon is on the Ethereum chain, right? It's on the layer one chain, and these layer two blockchains have these side chains, which also record transactions data and basically transaction history, right? It keeps the ledger basically where all the transactions go in. So that's what layer 2 does, and that's what a sidechain does. Now that's more onto the application layer, as you are building something on top of layer 1, and you are making it more sustainable, you're making it have more features and stuff. Now let's talk about layer 3. Now, like, except layer 1 and layer 2, there are other layers as well. Some being layer 2, layer 3, layer 4, layer 5. So these layer 3 and 4 and 5 are quite similar, and these are on the topmost level of the blockchain, where it mostly, it mostly just interacts with the user. Okay, like, see, for example, a layer 3 blockchain, a layer 3 system is something that is built on layer 2 or layer 1, which basically, like, see, you're building a Dapp. Okay, you're building a Dapp, and that's actually working on the layer 3, because it's interacting with the user, it's providing you features and stuff. You're doing stuff on the layer 1 and layer 2 blockchains. So yeah, that's how basically layer 3 works, and all the other layers as well kind of works the same way, such as layer 4 and layer 5. And yeah, let's move forward. So you've probably heard about these buzz terms such as multi-chain, omni-chain, cross-chain. Now, what exactly is the difference between these chains? So see, one omni-chain is basically a blockchain that has multiple assets. It's a blockchain that is self-sufficient, a blockchain that does not really need any other blockchains. Like, it does not really need to interact with other blockchains basically, because it's a single blockchain which has multiple assets on it, multiple tokens on it, and that's how the whole omni-chain thing works. And what is multi-chain? Multi-chain is basically, like, it's a chain of multiple blockchains which are connected together, and they have, like, they're already connected together, right? And then you are transferring token, you are swapping token, you are sending messages, you are transferring asset and doing different stuff on that multi-chain ecosystem basically. Now, what is cross-chain? Okay, see, interchain is also called as cross-chain. Now, in this session, we will be mainly talking about cross-chain, like what exactly cross-chain is. So, cross-chain, see, for the cross-chain part, it's mainly different blockchains that are not really, that can talk to each other, that can interact with each other, but they are not exactly connected, right? Like, in a multi-chain ecosystem, those blockchains are already connected, and then you are transferring token, you're transferring asset and all that, right? But in a cross-chain situation, you're interacting with a blockchain that does not really have any kind of similarities, or it's not part of that particular ecosystem, right? Like, say for example, if we are sending transactions from a Polygon blockchain to a Solana blockchain, right? See, so Polygon is related to Ethereum blockchain, which is a layer one blockchain, and Polygon itself is a layer two. And then it's trying to interact with Solana blockchain, where Solana blockchain is totally layer one. So it does not have any connection, like it's not part of the same ecosystem basically. And that's what Crosschain basically offers, Crosschain tools and all. So why do I need cross-chain? Like, see, I was mentoring some of the projects today, and I saw many of the projects like where you guys are building e-commerce projects, where you are talking about like how you are, trying to get a big user base. You are trying to, like trying to make a platform which is kind of like ONDC, which works. Which interacts with other sellers and then sell directly to the customers, right? So in those e-commerce projects, what you can do is integrate cross-chain protocols. And why exactly? Thing is, see, if you're building a dApp on particular one blockchain, you're restricting it to that particular blockchain. And you like, suppose if I have tokens on my MetaMask wallet, and like the app is built on Ethereum, okay, like MetaMask is the native wallet to Ethereum blockchain, right? So suppose I have funds in my MetaMask wallet, and what I want is that the project, say for example, the whole dApp is built on Solana ecosystem. So how do I interact? I can't actually like interact with Solana blockchain when I have funds in my MetaMask wallet, right? So what I can do instead is that I can set up a transfer bridge. I can set up such cross-chain protocols where I will be transferring tokens between wallets, like between different wallets, such as like if I have funds in my MetaMask, I can send those funds to my Phantom wallet, right? So that's how basically it works. Like, you can definitely check out all the cross-chain protocols I will be mentioning afterwards, and that's how you can get started. Also, cross-chain protocols gives you more liquidity. Now, what is liquidity? Liquidity is basically how fast and how easier you can buy or sell a token in a marketplace. And see, it's giving you more liquidity because it's connecting to multiple chains. It's giving you a larger user base where you can, build stuff on. Like, it's giving you a bigger marketplace, a bigger opportunity to grow, and it's making your DApp future proof. What do I mean by future proof is that it will make your dApp go cross chain, and then like you can attract customers who are on the other side of blockchain. Like, say for example, you have built something on Ethereum blockchain and you want to attract customers who are on the Solana blockchain, right? They have their funds on Solana blockchain, so they can transfer directly and be a part of your marketplace using these protocols. Okay, so which protocol to use? Now, there are multiple options you have, and we will be talking about two main protocols in this session, which are wormhole and router protocol. But there are different protocols as well. Like, there are different protocols, for messaging stuff, for transferring asset, and like each of those protocols have something new in them. They do something provide new. So yeah, you have multiple options. So these are all the options that are like really popular that you can actually try out. But in this session, we will be mainly talking about wormhole and router protocol, as I mentioned, because those are some protocols that like really do the job. They are easy to implement. They are super fast. They take super less fees as well. So yeah, except those, you can, if you're like building a messaging dApp and like, or trying to build something where you get notifications from different blockchains, then you can go for push protocol. like for chat and notification stuff. Then you have Polygon Bridge as well. Now, many of you are probably building on Polygon because Polygon is giving you a bounty. Now, thing is, in Polygon blockchain, no, not the Polygon blockchain. My bad, sorry. The Polygon bridge. The problem is that it only supports very less number of tokens. Like, see, one token being the Polygon POS, means the Polygon proof of stake token. Then there is Polygon zero knowledge EVM, and then there are Ethereum and some other USDT and other tokens as well. But yeah, mainly it doesn't actually like has a bigger market. It doesn't actually have too many options you can choose from. You can also try out Connext and Layer Zero. So yeah, let's jump right into Wormhole. And before that, let's check out if you guys have any questions or how you guys are interacting. Hi, hi, hi. Sorry, something is wrong with my glasses. Lol. Hey, Arav, thanks. I hope this is fun. Yeah. So can I actually click on this? Okay, I can't. Hold on a second. So let's deep dive into how wormhole exactly works. So see, wormhole. Like now, what is wormhole exactly? Wormhole is wait, yeah. Wormhole is a bridging protocol basically. Now, what I mean by bridging protocol is basically how cross-chain works, how all this, data transferring, this token transferring, and all that stuff works, right? So you can do all that using Wormhole. You can bridge tokens, you can transfer assets such as NFTs, tokens, and you can even send messages. You can do plenty of stuff on Wormhole, basically. So wormhole in the wormhole architecture, there are two stuff that are very important, like that actually sums up the whole architecture. Like I'm not going much deep into the whole architecture because then it will take up a whole session. And so I will be mainly talking about the two important points it has. One being the attestation and another one being the transfer feature. Now, what is the attestation? Like, what does it even do? So suppose you have Ethereum, right? You have Ethereum in your MetaMask wallet. Now, see, MetaMask wallet is a wallet that is native to the Ethereum blockchain, and Phantom is a wallet that is native to the Solana blockchain, but it also supports Ethereum and Polygon. That's a different scenario, but yeah, it's mainly native to the Solana blockchain. So, what this attestation process does is that suppose you have Ethereum in your ETH mainnet in your MetaMask wallet. Now, what you want to do is you want to send those Ethereum from your Ethereum mainnet to your Solana mainnet, and like how does exactly will it work? So, using Wormhole, what happens is that you can send these Ethereum tokens. First, what will happen is that uh, in this attestation process, the Ethereum tokens will first be minted on the Solana blockchain. So how exactly will it work? एक mint कैसे करेगा? See, first it will mint, but before that, on the Ethereum blockchain, metadata and address will be recorded. Like metadata and address of the token जो हमें भेजना है, and for that वो क्या होगा? Like वो करने से क्या होगा? Ethereum will be able to exist on Solana blockchain. Now we can't directly send Ethereum to Solana because Ethereum to Solana. Yeah, right. So why is that? Because Ethereum, the Ethereum or ETH token basically is native currency of Ethereum blockchain. So you can't directly send it to Solana blockchain just like that. What will happen is that in the attestation process, you can this wrapped ether will be minted on the Solana blockchain. Now, what is wrapped ether? We'll be coming back to it a bit later. Now, first, these Ethereum from your Ethereum mainnet will be locked, and then uh, the wrapped ether will be minted on your Solana blockchain. So what happens is that these wrapped ether uh, are basically ether but on Solana blockchain, and these are just like these will work just like Solana's native token Solana or any other native token it has. It will work just like Solana's native token. Okay, I am having some internet issue. Hold on a sec. Yeah, yeah. So wrapped ether is then minted on the Solana blockchain. Now what happens is that these wrapped ethers have the same value of ether that you are actually sending to the Solana blockchain. Now in the transfer process, what basically happens is that the minting is done. Now you can get those wrapped ether in your wallet, in that phantom wallet of yours in your Solana blockchain. अब क्या होगा? See, once the transfer part is done, now उधर तुम्हारा जो मेटामार्क्स में जो इथेरियम पड़ा था, that is now locked, and those same equivalent amount of ethereum being transferred as wrapped ether is now on your phantom wallet. Now what will happen is that you're done bridging it. Okay, now what if you are trying to reverse the process? You are trying to get back those ethereum in your metamask wallet. For that, तुम्हें क्या करना पड़ेगा? You will have to burn those wrapped ether on your Solana blockchain. You can just burn it. You can just burn it, and it will give you those ethereum that you staked, those ethereum that was locked, basically not staked, actually that's a different scenario, but those ethereum which was locked on the ethereum mainnet, वो अब खुल जाएंगे basically, and you can get those in your metamask wallet back. So that's how the reverse bridging works, by burning the tokens, and you can just get back. And this is how the wormhole architecture looks like, basically. You can take a deep dive into it, and I wrote a blog on this. That blog is kind of like a research paper, honestly. Like it has like in depth everything that you might need this. So okay. Hold on a sec, let me connect my YouTube channel. I will send you guys the blog post, and it should be good to go. Comment has failed to post. Okay. Uh, Hold on. Instead, I will send you to one of your members, and you guys can send it. Yeah. So go through this blog, and उधर मैंने बहुत कुछ डिस्कस करा है. Like I have given you hackathon ideas, I have given you multiple, you know, stuff you can actually work on, features you can work on, and I have given you the idea of the whole architecture, basically. Like कैसे wormhole करता है, and in depth. So as a developer, it's a gold mine for you. And also, if you try out the wormhole documentation, like इधर तो मैंने actually कुछ code snippets नहीं डाले, but what you can do is you can just search of the wormhole documentation, and उधर ना connect wormhole करके there will be, like I have also mentioned this in my blog, there is this connect wormhole front end widget which you can directly integrate to your marketplace or anything that you are building. Okay, so Udhar, if you can directly integrate it, what happens is that it's kind of a widget where, like, I can't exactly show my screen right now, but it's basically works like, see, you can connect to any of your wallet there, any of your two wallets, and then you can like choose any of the blockchains, you can choose any of the tokens that you want to transfer, and you can just do it. It's that easy, honestly, and it takes very nominal fees, and the whole path will be given to you by wormhole, like, so that it takes less fees. They will take in charge of that. So let's talk about router protocol now. What exactly is router protocol? So router protocol is a solution introduced to address the issues hindering the usability of cross-chain liquidity. Well, ये पढ़ने से कुछ actually like समझ नहीं आया what exactly router protocol is, right? So see, in very easy way, if I can, like, if I have to like explain it to you in very easy way, then router protocol is similar to wormhole, but their architecture is different. Like how they're working, like how the whole architecture looks like, and how they transfer those assets and stuff. That actually differs than wormhole and is different totally. So a router protocol comes from router. Now, what is router? Router is a layer one blockchain. Like it's a blockchain solution of course. Router protocol whole as a, it's a protocol which is meant to be like make it easy for you to send those assets and tokens and stuff cross chain. And router is a layer one blockchain basically. So it has an own blockchain of its own, and it has token of its own as well. So it has tokens which is called router, not router, I believe it was route instead. Yeah, so these route tokens, you will be needing these when like you will have to, you know, bridge your assets to like different marketplace and stuff. You can get those easily from testnet and stuff. So yeah, and what this protocol does is that it's basically a magical bridge. It connects layer 1 and layer 2 blockchains that easily. Now, what is router nitro? Router nitro is a protocol designed to enable cross-chain asset transfer. Like I mentioned above, it's a protocol that enables cross-chain asset transfer. And in this session, we will be talking about the router nitro mainly. Like I will be giving you a brief idea of how the architecture looks like. So also, a router is built on Cosmos SDK, and I'm not going much depth into what Cosmos SDK is all about. You can search it up on yourself, and I definitely, I mean, you guys should actually check it out, like what Cosmos SDK is and how you can build smart contracts on it and how a blockchain on it exactly works. So also, yeah, it serves as a mechanism for seamlessly moving digital assets or tokens between different blockchain networks. Cool. So yeah, here is the whole architecture. So building via Nitro, the router Nitro is a three-step process. There are three steps into it, and I can't exactly. I think my, oops. Oopsie. Okay, I can't exactly show my whole screen here, but yeah, sure. Yeah. So router Nitro mainly has this uh, three features, or you can say like three parts of it, of how the whole process exactly works. The first being the get the code. Now, what do we mean by get the code? Like, so you have to request for a code basically, and for this, for requesting a code basically, you will like there are two ways you can do it. First, you can do is define a pathfinder URL on the router testnet, and also you can do is that you can build. I mean, you can just write. Get code function on smart contract, and that contract will have these parameters. It will have the source token address, it will have the destination token address, the my bad, the source chain ID, destination chain amount, and everything. Cool. So you're given all this data, all this info directly to the code, to the function. And okay, once you're done sending it, now comes the part of check and set allowance. Now, what happens is this what happens here is basically in the whole set allowance, like in this process, it will check whether the allowance you sent, like, see, this is more of an configuration and confirmation of the transaction part, where you are actually confirming and configuring the whole transaction basically. So for this, you can check whether uh, the allowance is lower than what is required. You can check whether it's lower than what is required, and if it is, then what it does is that router nitro asks to withdraw tokens from your wallet, and then you can like set it up, and then this set allowance, this whole process works, and you're getting a transaction ID basically. You're getting a hash ID. Now you can do the transaction. I can't exactly show this. Really sorry, I made this PPT just a few hours ago before taking on the session, so I couldn't actually uh, expand on it, and I couldn't actually make much like multiple parts of it. So in this execute the transaction function, you will have different, different functions or different parameters, such as this code data. See, you are getting the code data back from get code, right? So that code data, then source token address, destination token address, sender token, receiver token, and there are multiple parts of it. If you can check the mm, if you can check the whole documentation of it, the router nitrous documentation and the whole architecture part, then you can actually understand what these parameters will do and how it will execute the transaction. Again, I'm not going much depth into this, but all these parameters will come into help to actually confirming that transaction. And once that transaction is confirmed, you can get those tokens or assets back to your wallet, like while you are trying to send. Okay, now comes the part of hackathon ideas. Before that, hold on a second. Okay, so I'm providing some of the uh, materials that you might find really useful in the whole hackathon. I will be sending it to the comment section. Give me a minute. You can check out their Medium profile, and you can get all those materials to actually work on to understand the whole architecture. Spanish. Okay, I will be sharing my screen instead, so you guys can see exactly what I'm talking about. Yep. So I think that's visible. Yeah. Cool. So see, uh, okay. This is the whole architecture where, like, yeah, I have talked about what attestation is, what transfer is, and what exactly, like, how you can even like attest from Solana to Ethereum and all that. You guys can definitely go through all this, and also what I'm trying to show is hold on, yeah, check this out. Let me stop my screen once. Yeah. So see this. This is basically the widget part of Wormhole Connect, which I was talking about previously. So if you just click on Get Started, you can get the code from here, okay, to deploy. And like it's basically like it will take around like 1 or 2 lines, and that's about it. So yeah, you can do it on HTML, you can do it on React as well. So yeah. Um, First, let me show you what exactly it looks like and how exactly it works. So you can select any of the networks here. Oh, hold on a sec. Yeah. So you can select any of the networks here. So as I'm selecting the test nets, so I can choose any like Mumbai testnet, for example, right? So Mumbai Polygon testnet, and we can like send our um, we can send to Solana our assets to Solana. Yeah. So like which asset now? Let's say, see, this is what I was talking about previously. Wrapped Ether on Goerli, as Ether is the native currency of Ethereum. Like if you are sending it on like a Polygon blockchain or even the test nets, then of course it will be a wrapped Ether instead of the actual native token Ether. So you're sending wrapped Ether to wrapped Ether, and from Mumbai to Solana, right? So here you can even connect your wallet. Like for Ethereum, you can only choose MetaMask. Like this is only the testnet part, I guess. That is why they don't have that many options to choose from. But if you actually integrate it, there can be like you can even add stuff on your own. Like see all these wallets you can choose from for Solana. Just like that, you can also choose Wallet Connect and other wallets on other native wallets on the Ethereum blockchain. And see, this is the route basically. This is the route via this cross-chain transaction will happen from wrapped Ether to wrapped Ether, from Mumbai testnet to Solana network. So this is how it will work. Like once I do the connect wallet part, I can just do it on my own, and you can get the the code from here as well, and you can even customize it. Like you can change the styling and all routes and stuff. So let me get back to the blog. Yep. So I have also provided some of the reference links that we were talking about previously. And yeah, let's talk about projects now. See, here I have given a list of wormhole projects, but you can also build all this stuff on the router protocol as well. And yeah, free UI. Yeah, that's the best part. Actually, router protocol has this free UI as well, which you can integrate in like 2 lines of code. So yeah, both actually are very viable and both are easy to integrate in your marketplace or anything or any Dapp you're building. So yeah, I think this is visible. Yeah. Yeah, so the first project idea being the cross-chain RWA based project. Now, what is RWA? See, here as I mentioned, RWA is basically real estate investment, carbon credits, and all those assets and stuff. And the like, what you can do is make NFT out of them. You can actually, build something like you can basically tokenize the real world assets and then build the projects, right? And you can make them cross chain, like instead of actually like restricting them in one particular blockchain, you can make it go cross chain. So you're having more user base, you're getting more liquidity, and you're getting more exposure as well. So also for cross-chain borrowing and lending platform, this is one of the most basic use cases, I would say. Like this is something that many of the blockchains, like many of the projects that are initially beginning, those blockchains or those projects actually do this stuff like borrowing and lending platform and stuff. So yeah, you can definitely work on this. And Pika Finance is one of the reference. Like it's built on wormhole and it provides universal liquidity. Also, then there is multi-chain identity management system, like one identity for everywhere. Like if you have like I don't know if you guys have heard about unstoppable domains, where you can like have one domain and like build on cross chain, like one domain for every blockchain. There is one particular identity for everywhere, right? So this concept is kind of similar, like a identity management system, which is multi-chain or cross-chain. Then there is cross-chain NFT marketplace, which is very basic stuff. Cross-chain NFT marketplace has this, it like the best part about it is that you're getting more liquidity and getting a huge user base. And yeah, Carrier is one of the reference. And then there is interoperable data oracles. Now, data oracles mainly, if you have probably heard about data oracles from Chainlink, and this mostly works on off-chain stuff. So yeah, you can also work on this. And I'm not going much deep into any of this like Dex aggregator, multi-chain gaming platform. Okay, there are multiple hackathon ideas that you can like build on. And also you can also build you can directly integrate these protocols to your marketplace or anything at all, like your Dapp, honestly. So I was talking about router protocol, and yeah, about that, let me give me a minute. I kind of want to show the actual image because uh, if I find that only, hold on. Yeah, let me stop the screen once and get back to this window. Yep. Yeah. So go through this documentation. I'm not like, again, I have around 9 minutes left, so I can't exactly go much deep into all this, but you can definitely check out this router SDK, this cross chain. Like they have this protocol called cross chain talk. Like it's a library basically. And if you go to the developer documentation, yeah, I believe many of the projects will need this asset transfer, not the message transfer maybe, but asset definitely. Like yeah, if you use Nitro, then this is the reverse verification flow, and yeah, this is more of the high level flow, not this honestly. Let me give you the overview instead. Hold on, what is that? Yeah, see, this is what I was talking about, the crosstalk library. And yeah, you can definitely like check out the documentation here and like build on your own a sample idea. Like hopefully if there are, yeah, see, so cross chain ping pong, this is one of the sample EVM IDAPs. Now what IDAPs is basically, it's just full form, or I mean short form of interoperable dApps, right? So see, for IDAPs, like cross-chain ping pong is one of the example, cross-chain NFT is one of the example, and these are very basic stuff, and these are on the EVM chain, means the Ethereum blockchain. Now you can also build on Nair protocol, Nair blockchain. Okay, like yeah, see, here are some of the like boilerplate and stuff, like how to get started on Nair, like dependencies using cargo, creating a helping function, external function, and yeah, you can check all this out on yourself. Honestly, just search about router SDK or router documentation, and that will be enough. And give me a minute. Yeah, so that's almost about it. Now, uh, you can also try out these options as well. Like, but I would personally suggest you to use wormhole and router protocol because they have like better documentation, better user friendly experience, and yeah, like as Arav mentioned, like they have these widgets ready to deploy. So yeah, that's about it. And if you're like planning to build on messaging protocols, then you have different options such as push protocol and uh, even huddle. Like if you are trying to do stuff on like chatting or token gated rooms and streaming and all that, and all those work on cross chain. So yeah, that's about it. Keep building and all the best for the hackathon. And that's all. I am concluding my session. Thanks to everyone who joined. Thanks to GDC Triple IT Kalyani for giving me this opportunity. And yeah, I hope all these documentations I provided, all these materials I provided, all this explanation I gave. I hope all this came to help and you get to learn something new. And I believe many of you will be transforming your dApps and building on cross-chain instead of one particular blockchain, because the future is cross-chain. And like you are basically like I heard many of the projects, like many of the mentees told me that they're planning to build on mainnet. Like for now abhi ke liye they're doing on testnet, but they're planning to do stuff on mainnet. So yeah, if you have big plans like that, then you will definitely have to look on the business aspect, and then you will have to look on like how exactly you can make your dApp future proof, right? So yeah, that's all about it. Thanks for joining this session. And yeah, keep building.